guys, welcome to my channel. I'm Undirected. If you guys are new here, I pretty much do leetcode style questions and I explain things in the simplest way possible. Today we have a pretty interesting topic for you guys. We're gonna be talking about graph, guys. So a graph is a non-linear data structure, guys. A graph is made up of two basic components, right? Made up of nodes, right, which represents objects, entities, right, and then it's made up of an edge, right, edges, right, and which represents the relationship between the different nodes, right, I'm saying, in the graph, right. So pretty much an application of the graph, guys, can be, let's say we have a social media network, right, and we have different users on the platform, right. So let's say we have a J, right, for Undirected, and we have another user that's called Sam, right, and then let's say we want to become friends on that platform, right. I would send that person a friend request, right, and we would become friends on there, right. So we draw an edge, guys, to show the relationship between the different users, right. So in this scenario, right, we see that that the different users, right, they represent nodes, right, in the graph, right, I'm saying, and then the edges, right, shows pretty much the relationship between the different users on the platform, guys. So that's the application, guys. So let's say we introduce a different user, and let's say we introduce Paul, right. Paul has no friends, right. So Paul doesn't have any edges connecting them to any other nodes in the graph, guys. So that's one example, guys. There are plenty of examples. I'm saying that they use it for Google Maps, right, different type of applications, right, I'm saying, which can represent routes and stuff like that. So their graphs are really cool, guys. So let's start talking about the different types of graphs, guys, we have, guys. So we're gonna be covering, guys, this first thing we're gonna cover the undirected graph, guys, right. Undirected, right. So this graph, right, let me just draw pretty much, the edges, right, I'm saying, are bidirectional, guys. So I'm gonna show you guys an example real quick. Right. So this one, right, this example, right, the edges, right, this edge, right, pretty much it's bidirectional, right. It can go either direction, guys. We can go from 1 to 2, or we can go from 2 to 1, right. We could easily do that, right, because because of this edge, right. This represents an undirected graph, right. So which is a pretty good one. So next we're going to be talking about the other one, directed graph, which is the opposite of, what I'm saying, which is different than the undirected, right. So let me just do this real quick. Directed. Sorry for my bad handwriting, guys. It's happening fast. Directed, right? So this one is pretty interesting. So this one, pretty much now the edges, right, they're directed, guys. So which is different than the undirected graph, right? So let me draw them so make sure that you understand what I'm saying. 3, 4, right? I gotta make sure I do that. So this one, right, you can see that we can go from, with this edge, right, we can go from 1 to 2, right, but we cannot go from 2 to 1 directly like that, right. No, it's not the same thing because it's directed, guys, what I'm saying. So we can't do that, right. So you could think about it, this is like a one-way street, right. It can only can only come from 1 to 2, right, directly, what I'm saying. Can only go in that direction, right, for this route, right. So for two to be able to get to 1, right, 2 will have to go all the way around, guys. 2 will have to go from 2 to 3, from 3 to 4, and from 4 to 1, right. So for it to get to 1, guys. So that's the difference with the other undirected graph, guys. So the next one I want to cover, it's the weighted graph, guys. So weighted, right. Weighted, I'm saying, so this one is interesting, right. So this one, now the edges, right, they have an associated cost with them. So so now I'm going to draw the same ones again, right. Same 2, right, 3, 4, right. So we have this right now, right. We can go from so the cost, right, let's add a cost, right. Let's add 10, 5, right. Let's say now from, so this one, you can see there are values, right, associated with each of the edges, guys. So that's what we mean by weighted, guys. There's a cost associated with the edges now, right? So that's a type, right? So let's say for this one, right? So the cost can be whatever unit you want it to be, you know what I'm saying? So to get from 1 to 4, guys, what I'm saying, from 1 to 4, right, we could take this route, right, which would cost us about 30, right? I'm saying, which is, you might say, oh yeah, that's pretty good, but we could find one that's less, right? Let's say one of the least cost, right? You know what I'm saying? We don't care about, you know, the distance, right? Right. So what this would be, right? I'm saying the edges, right? So I would rather take this route, right? Go from 1 to 2, right? Which would take me about, you know, 10, right? 10 units, and then from 2 to 3, right, would cost me another 5, which is 15. And then from 3 to 4, guys, would give me a total cost of 20, guys, which is less than the 30 cost of going directly from 1 to 4, right? So I would rather do that if I wanted the lowest cost possible, right? So that's one application, guys. What I'm saying, application of that could be, let's say, you know, those nodes, right, represent like cities, right? I'm saying, and then the cost, right, represent like, you know, the amount of time, right, that it would take to go from one city to the next, right? And yeah, so let's say it will take me 30 minutes, right? Let's say 30 minutes to go from 1 to 4, because there are lots of traffic in that particular spot, right? Yeah, I would probably skip that one, what I'm saying. So that's one example, right? So the next one that I want to cover, right, is the cyclic graph, right? So this pretty much means, guys, this is a graph with cycles, guys. So a graph that has cycles, guys. So if you notice throughout this video, right, I've been drawing pretty much a lot of cyclic graph, guys. So there are cycles, right? Pretty much we could easily see this is a cyclic graph, guys, because there's a cycle, guys, because we can start at node 1, right, and also end at node 1, guys. So we can go from 1 to 2, from 2 to 3, from 3 to 4, and from 4 to 1, right? Because we start and end at the same node. You know what I'm saying? So that's a cyclic graph, guys. So that's how you can see to see if a graph is cyclic or not, right? So the other one, which is different, right? It's the acyclic one, right? So pretty much this one means the opposite, right? You know what I'm saying? There are no cycles in this graph, right? So that's very, very important. So let me just draw an example of that, right? 2, 3, 4, right? So this one is acyclic. I'm saying we can't start and end at the same node, right? You know, if we were to, you know, go on a path, right? I'm saying, so we can go from 1 to 2, from 2 to 3, from 3 to 4, right? I'm saying, because we remove that edge, right, which is the same. I'm saying that edge does not exist, right? So we don't do that, right? I'm saying, so we don't have a cycle, pretty much, right? So that's what makes it pretty good, guys. So yeah, hopefully that kind of made sense, guys. So you guys found a lot of value in this video, guys. So there are other types of graphs, guys, but those are the main ones that we have to work out, right? So if you guys found value, guys, please give me a like, guys. I will appreciate that a lot. If you guys are new here, subscribe to the channel, guys, you know, as it would help grow this channel, guys, and really help me out a lot. So I want to thank you guys for watching this video, you know what I'm saying, and see you again in the next one.